Hello everyone. Previous class we see about the preparation methods and some problems based on the preparation of haloalkanes. Today we will discuss about the properties of haloalkanes. Alkanes, when replacing with the one hydrogen atom, they convert into haloalkanes or haloarenes. These are hydrocarbons. Nonpolar. Whereas the haloalkanes are polar in nature. Haloalkanes are polar in nature compared to the hydrocarbons from which they are derived. Because among of the haloalkanes, X is the more electronegative atom, so it acquires the dull negative charge, and alkyl group acquire the dull positive charge. Why they are getting charges? Due to the electronegativity differences. If you look at the halogen atom, fluorine, chlorine, bromine, iodine. And their electronegativities. Fluorine electronegativity value is 4, whereas the chlorine electronegativity value is 3, bromine 2.8, iodine is 2.5. Come to electronegativity of carbon, 2.5. So due to difference between the electronegativity difference between the halogen atom and the carbon, they are polar in nature. So haloalkanes are polar in nature compared to the alkanes from which they are derived. It is due to electronegativity difference between the carbon and the halogen atom. If you look at the bond of Cr, CCl, CBr, and Ci. Carbon is 2.5 and fluorine is 4. So electronegativity difference between the carbon and fluorine is 1.5, whereas the chlorine is zero point 0.5, bromine is zero point 0.3, and it is 0. Because so when come to this case, it is more polar in nature due to more electronegativity difference between the carbon and the fluorine atom. And it is a non-ionic substances because they are not going completely dissociation into positive and negative ions. It is polar in nature but not an ionic substance because electronegative difference between the carbon and fluorine is 1.5. More than 1.7 electronegative difference only in the compounds behave like as a ionic substances. Less than 1.7 covalent in nature. So these are covalent substances, even though they are in polar in nature. Next one is haloalkanes. Contains halogen atoms. Halogens give color when they exposed to the light. But come to the haloalkanes. Bromine and iodine. Bromoalkanes, iodoalkanes are colored substances. That means they give color when they expose to the light. But fluorine and chlorine, they do not give any color when they expose to light. Individually, fluorine is pale yellow color, chlorine is greenish yellow color. All halogens are colored substances. But bromoalkanes or iodoalkanes are only colored among of the haloalkanes due to their size of the halogen atoms. It is the first point among of the physical properties. These are polar in nature. Number two, bromo and iodoalkanes give color when they expose to the light. It is due to the electronegative difference between the carbon and halogen atom. Well, look at it, there is no electronegative difference between the carbon and the iodine bond. That is almost how this substance is a non-polar compound, right? More important, as per the 2 marks question of your IP are MCQ boiling points. These haloalkanes are liquids at room temperature. These all are liquids at the room temperature. When come to the alkyl halide and alkanes, the boiling point of haloalkanes are greater than parent hydrocarbon. It is due to large halogen atom, increase in intermolecular forces and polarizability. Due to these three reasons, the boiling point of haloalkanes are more than parent hydrocarbons. For same alkyl group, R is same in such cases. The boiling point order is hydroalkanes are more boiling point than alkyl bromide, then chloride, then fluorides. Due to large halogen atom. When come to the fluorine to iodine, size of the halogen atom increases. Increasing the size of the halogen atom, the intermolecular forces, that is, increase in van der Waals forces. Due to increase in van der Waals forces, the boiling point of hydroalkanes are more than bromide, then chloride, then fluorides. For same alkyl group, most important. In isomeric halides, when they are isomers, in isomeric halides, boiling point decreases with increase in branching. The same alkyl group, this is the order. In case if the compounds are having a similar, that is same halogen atom, different alkyl group, that is in isomeric halides, boiling point decreases with increasing in the branching. Got it? Why the boiling point decreases due to increasing in the branching? Because surface area will be decreases. Increasing in the branch, the molecule surface area will be decreases. Therefore, the boiling point of the halogen, haloalkanes decreases with increasing in the branch. So this is the one of the part as per the IPE important boiling points. Repeat again. Haloalkanes are liquids at room temperature. The boiling point of haloalkanes are more than the parent hydrocarbons due to large halogen atom, increasing intermolecular forces, that is van der Waals forces of attraction, and polarizability. This word you can be heard in the chemical bond to explain the nature of the chemical bond present between the two atoms. That is Fazan's role. So, due to these reasons, the boiling point of the haloalkanes are more than the hydrocarbons. For same alkyl group, the boiling point order is hydroalkanes are more than bromides, chlorides, fluorides. It is due to increasing in the van der Waals forces. Whereas in isomeric halides, boiling point of haloalkanes decreases with increase in the branching. What happens when branching increases? Due to increasing in the branching, their surface area will be decreases. That the most atoms come closer to each other. They become has to be somewhat spherical in nature, so that their boiling point will be decreases. For example, bromine and propyl bromide. One bromo butane, two bromo butane, and come to the two bromo, two methyl propane. Now these three are isomeric haloalkanes having the same halogen atom. Now come to this N chain, iso chain, and come to this tertiary chain. Compared to the first one, second one have some branches. Compare the second one, third one is more branch. They come closer to each other. That means having what? somewhat spherical in nature. So due to decreasing in the surface area, the boiling point order of these three of C4H9 Br, example of these three are isomeric products. Now one is more than two, two is more than three. To the reason nothing but the increasing in the branching, the boiling points are decreases. Tertiary butyl bromide having more branching in nature, so all the molecules are come closer to each other. That means this molecule becomes into the spherical in nature. So the surface area will be decreases. Due to decreasing of surface area, their boiling point will be decreases. So it is one of the important point as per the IPE to ask a question of 2 marks, boiling point of the haloalkanes. They may ask, they give one of the molecular formula of a compound and try to arrange the molecule in the increasing or decreasing order of their boiling points. Okay. Next one. Come to the density. Same reason, haloalkanes are more denser than hydrocarbon, increasing in the size as well as the mass of the halogen atom. Increasing number of carbon atoms, number of halogen atoms, and mass of the halogen atom. Their densities increases. More size and having of high molecular weight, high molar mass. The density of the halogen atoms are more comparing with the respective of hydrocarbons. Increase in number of carbon atoms and number of halogen atoms and mass of the halogen increases. The density of the halogens also increases. Dipole movement. When comes the carbon and halogen, due to more electronegativity of the halogen atom, these electrons are moved towards to the halogen. So polar substances can have some dipole movement. What is dipole movement? It is the product of charge on the either of the dipole molecule and distance between these two atoms is known as the dipole moment. It is the product of charge on the either of the poles of dipole molecule and distance between the two atoms is known as the dipole moment. It is represented mu is equal to dou into L. Methyl chloride, methylene chloride, chloroform, carbon tetrachloride. Methyl chloride, methylene chloride, chloroform, carbon tetrachloride. If you arrange this molecule in the increasing order of their dipole moment or decreasing order. As I said, this bond between the carbon and halogen atom in haloalkanes is polar in nature. That is due to electronegativity difference between the carbon and the halogen atoms. In all these molecules, a single carbon atom is present. All are saturated hydrocarbons. So, in this each atom, each carbon atom is involved in sp3 hybridization. So, as per the sp3 hybridization, the geometry of the molecule is tetrahedral. It is the tetrahedral geometry of the carbon. Now, what is the chlorine, hydrogen, hydrogen, hydrogen? Between these two, which is more electronegative now? Chlorine. So all these atoms, this electron pair move towards to the chlorine. Compared to the carbon and hydrogen atom, electronegativity of hydrogen is 2.1, carbon is 2.5. Which is more electronegative now? Carbon. So these electrons move towards to the carbon side. So all the electrons are moving towards the more electronegativity of the chlorine atom. You see the dichloromethane or methylene chloride. Now these electrons are these bond pair of electrons move towards the chlorine side. These bond pair of electrons of carbon hydrogen move towards the carbon side now. Look at the chloroform. This bond pair move towards the chlorine, and these bond pair move towards the this chlorine atom, and this one come to the below. And the bond pair present between the carbon and hydrogen move towards the carbon side. When we come to the carbon tetrachloride, when you observe these two molecules, they are in opposite in nature. So the total net dipole moment of this molecule is equal to 0. So carbon tetrachloride dipole moment is equal to 0. Whereas the remaining three net dipole moment is not equal to 0 because there is a difference in the moving of electron pairs. Compare these three cases. When this chloromethane or methyl chloride of all bond pair of electrons are moved towards the chlorine side only. So methyl chloride or chloromethane net dipole moment is more compared to the dichloromethane or methylene chloride comparing with the chloroform. As per the experimental data, the net dipole moment of chloromethane 1.94. It is 1.6, whereas it is 0.9, whereas it is equal to 0. So among of these four products of that is poly, halo, or chloroalkanes of methane, arranging in the increasing order or decreasing order of the dipole moment, which will be more known methyl chloride or chloromethane is more dipole moment than comparing with the methylene chloride, then chloroform, then carbon tetrachloride. So the order is more. It's an important one, asked for the 2 marks question, or maybe asked once in the examination of MCET also. Among of the polyhalogen of methane, which has more dipole moment. So which will have now chloromethane is more dipole moment than dichloro, trichloro, tetrachloromethanes. So it is one of the physical property which we can call as dipole moment. What is dipole moment? It is a product of either of the pole of a dipole molecule and distance between the two atoms is known as the dipole moment. It arises only when a electronegative differences is present between the two atoms in a molecule. Okay, so it is dipole moment of haloalkanes. So among of the physical properties, two are more important. One is boiling point of haloalkanes. Second one is the dipole movement. Okay. Now come to the chemical properties of these haloalkanes. So come to the any substances chemical properties. Generally chemical reactions are four types. What they are, one is substitution reactions. Second one is addition reaction. Third one is elimination. And fourth come under the rearrangement reactions. Substitution reactions, addition reactions, elimination reactions, and the rearrangement reactions. When it comes to substitution reactions, saturated hydrocarbons are participate in the substitution reactions, which contains single bonds. Second one, addition reactions. Any unsaturated hydrocarbon, that is double bonded or triple bonded compounds, alkenes or alkynes. The reagent molecules are added to these two carbons to convert it into a saturated organic compound. Those are called as the addition reactions. A reagent is added to the substrate molecule and converted into the saturated substances. And come to the elimination reactions. Saturated hydrocarbons of adjacent carbon atoms, removal of group, convert into unsaturated hydrocarbons are come under the elimination reactions. Elimination reactions are opposite to the addition reactions. In addition reactions, an unsaturated hydrocarbon is converting into saturated by addition of reagent. Whereas in the elimination reaction, in presence of a reagent, a group of atoms removed from the adjacent carbon atoms converting into unsaturated hydrocarbons. And come to fourth one, rearrangement. In this, any atom or a group will be migrated from one place to another place. Such reactions are called as the rearrangement reactions. So these are the chemical reactions we can observe in our organic reactions. So before going to the chemical properties, to discuss a little bit about reaction mechanism. Now the most important among of organic chemistry. You have to understand the reaction mechanism of any chemical reaction. It is better easy to write the product in a chemical reactions or chemical property of any substances having of different functional groups. So what is this reaction mechanism? A substrate molecule react with the reagent. It is nothing but what we can call substrate react with the reagent. In presence of a solvent, they forms an intermediate. This intermediate converting into products. A substrate combines with the reagent or reacts with the reagent in presence of a solvent, forms an intermediate. Then this intermediate is converting into products. That means in any chemical reaction, these reaction molecules converting into products through the formation of an intermediate. What are the intermediates? One is free radical, carbocation, carbanion. So any one of these intermediates can be formed in a chemical reaction that leads to formation of products. It is what happens in a chemical reaction. The substrate combines or reacts with the reagent in presence of a solvent, forms an intermediate which leads to formation of products. It is what the reaction proceeding through the different stages. Whatever reactions in whether substrate or reagent, any one of them are in solid in nature, they will be converted into liquids. Then, so that they use the solvent. So any chemical reaction must be take place in presence of a solvent because the reactions can be take place between the liquid molecules, but not in the solid state. So solvent make a vital role in any chemical reactions. Now come to the what is known as the solvent. Solvent is that which can dissolve this substrate or reagent molecules and combine together to form an intermediate. The solvents are two types. Polar solvents, non-polar solvents. Polar and non-polar. Because any of these solid substrate or reagent going to be dissolved in the solvent, then only they combine together to converting into products. So solvents are two types, polar and non-polar. Non-polar means do not contain any polarity. That is, they don't have any electronegativity differences between the atoms in a molecule. The well-known non-polar solvents are, for example, cyclohexane or benzene or carbon tetrachloride. These are some examples which are come under the non-polar solvents. Come to the polar solvents. For example, look at the water molecule. Among the water, between these two, there is a electronegativity differences. So, del negative, it is del positive. Now, this molecule is known as the polar molecule due to electronegativity differences. So, come to this. Water is used as a solvent, which is polar in nature. So, such solvents are called as the polar solvents. Among of the polar solvents are also two types. Polar protic solvents. A solvent which contains electronegative differences between the atoms is polar in nature. That polar solvents are also two types. One is polar protic solvent, which furnish H plus ion, which give H plus ion. Any solvent which produce H plus ion, which furnish, which gives, are known as the polar protic solvents. For example, water, ammonium. If you replace the H with an alkyl group, alcohol, carboxylic acids. These are known as the polar protic solvents, which furnish, which gives, or which produce H plus ions. Second one, non-polar solvent, which do not give or furnish H plus ion, which gives H plus ions are polar protic solvents, which cannot give H plus ion, which do not furnish H plus ion, which cannot produce H plus ion, are non-polar solvents. For example, look at this molecule. It is an example of polar, let me correct it. Polar Please let me correct. It is not non-polar. Polar aprotic solvents, which cannot produce the H plus ion. Look at this example now. It is acetone. Between the carbon oxygen, there is electron negative differences. So these electrons are moved towards to the oxygen. So oxygen will have a del negative charge, and carbon can have del positive charge. Now this molecule is polar in nature, but cannot produce any H plus ion. So such type of solvents are known as the polar aprotic solvents. Similarly, it's an example of ether, carbon, oxygen, carbon. So oxygen more electronegative. Between these two again, there is a del negative as well as del positive, but it cannot produce any H plus ion. In case of carbon, if we use this sulfur, dimethyl sulfoxide, it is known as the, it is an acetone ether dimethyl sulfoxide. Simply it is known as the DMSO, dimethyl sulfoxide. Between these two also there is electronegative differences. So it is also polar aprotic solvent. One more, so it is an amide function group called as the formamide, right? You remove these two hydrogens with the methyl groups. Now it is called dimethyl formamide, known as the DMF, dimethyl formamide. It is polar in nature, but it cannot produce any H plus ion. If you remove this hydrogen atom with the methyl group, dimethyl acetamide, DMA. So these are some examples which are come under the polar aprotic solvents. Why we need these solvents? Because the reaction proceed in presence of a solvent. Because all the here substrate or reagent molecules are not in the liquid state. So to convert them into liquid state, we use a solvent. These are two types, polar and non-polar solvents. Polar solvents are those which have the electronegative differences between the atoms in a molecule. Example, water and ammonia. Polar solvents again two types, polar rhodic solvents which gives H plus ions. Example, water, alcohol, acetic acid, ammonia, etc. Polar aprotic solvent. They are polar in nature, having of electronegative differences, but they do not produce or furnish the H plus ion. Such solvents are called polar aprotic solvent. One example for the polar aprotic solvent is acetone. Between the carbon oxygen, there is electronegative differences, but it cannot produce any H plus ion. Similarly, a simple ether. Ether molecule is also polar in nature because oxygen atom is present between two carbon atoms. If you remove the carbon with a sulfur atom among the H2, it converts into the dimethyl sulfoxide, DMSO. It is also one of the polar aprotic solvent. DMF, dimethyl formamide. Similarly, If you remove the hydrogen atom with the methyl group, that is, if you replace the hydrogen with the methyl group, it will convert into the dimethyl acetamide DMA. It is also acts as a polar electrolytic solvent. Second one, non-polar solvent. These are those solvents which do not have any electronegativity differences between the two atoms. Example, CCl4 carbon tetrachloride, cyclohexane, benzene, hexane, open chain molecule, that is saturated open chain compound. Hexane can also used as a non-polar solvent. The solvent make major role in a chemical reaction to proceed in forward direction to form an intermediate, right? So this solvent is more important as per the chemical reactions, that is properties. Any of the compound, whatever they may be. Okay, so it's the first part among of the reaction mechanism. I repeat again, a substrate react with the reagent in presence of solvent, convert into an intermediate that may be free radical, carbocation or carbene ion. Then that intermediate converts into the product. Why we using solvent means in the liquid state only chemical reaction will be take place. So that we use the solvent. Okay. And tomorrow we will discuss about the intermediates as well as the reagents. That we already discussed in your first year in general organic chemistry (GOC). Just look at once types of reagents and the intermediate. Okay.